And like also if anyone needs like a reference for a job, or if they like if anybody in this class is looking to thank you, Perspender, appreciate it. Yeah, they're looking for, yeah, I could yeah, that sounds good. I'll talk to them and see if they need any support. But thanks, Pushbender. Yeah, and also if anyone needs a reference for a job application or a visa, application, just let me know. Yeah, like a job application, like anything, like you need a reference, let me know, and I'll be a reference if you ever need it. Yeah. So we'll start. It'll be on sampling. So we're gonna go through sampling, and we already did the midterm, so don't worry about that. So we're gonna go through what sampling is: sample, population, element, sampling unit and subject, and then statistical terms in sampling. Then discussing the sampling process, and then looking at probabilistic and non-probabilistic sampling design. And then we'll go through sample size, taking into consideration the precision and confidence. Yeah. So yeah, sampling is important because we need to have a big enough sample to make up to, like, we need a big enough sample or else the results are going to be wrong. So the sample size has to be very high, or like, so the rule of thumb here is like you need either fully random sample or sample from a lot of people. So like you could sample like focus groups, right? You could have a focus group of like, let's say 10 people, and if it's fully random, like everyone is selected randomly, this will work, right? So like you could do it like that if you want, but if you can't get that, like if you can't get that, then you have to get like 100,000 people, 10,000 people to answer. So like here, that's, so for example, this is how they do like political polling. They do it like this because it's hard to get a fully random sample. But for this focus groups, they use those a lot for like market research or businesses. So like you can use either. Both work, but it's sometimes you can't get a good focus group. So those are ways you can sample. Yeah, focus groups are used a lot to like they're used a lot to determine what's good for the organization. So I'll show you a video about that. I'm just gonna, so we're on 5, so I'll bring up the video. So there's some good, So I'll put this on.
Yeah, I'm gonna call it right now. I think I found the single biggest productivity hack of 2021. It's this Google Chrome extension.
Why do we buy certain products or choose certain brands? This is the sort of question advertisers have always asked, and there are no easy answers. However, there is a handy tool that helps companies explore this and similar questions, and it's called the focus group. Until the 1940s, market research was often quantitative, using things like sales figures and customer polls to track consumption. But this changed during World War II. Sociologists Robert Merton and Paul Lazarsfeld set out to learn how unprecedented exposure to wartime propaganda was affecting the public. Instead of polling large numbers of people with straightforward questions and quantifiable answers, the researchers conducted in-person interviews, sometimes with small groups, engaging them in more open discussions. Later, this method was picked up by the advertising industry with the help of consultants like Austrian-born psychologist Ernest Dichter, who first coined the term focus group. This new technique was a type of qualitative research, focused on the nature of people's preferences and thoughts. It couldn't tell marketers what percentage of people buy a certain product or brand, but it could tell them more about the people who do, their reasoning for doing so, and even the unconscious motivations behind those reasons. Rather than providing definite conclusions for business and sales, focus groups would be used for exploratory research, generating new ideas for products and marketing based on deeper understanding of consumer habits. For example, early focus groups found that contrary to popular opinion at the time, wives often had more influence than their husbands when choosing which car to buy. So Chrysler shifted gears by marketing cars directly to women. And Dr. Dichter himself conducted focus groups for Mattel to learn what girls wanted in a doll. The result was the original Barbie doll. So how does a focus group work? First, companies recruit between 6 and 10 participants according to specific criteria that meet their research objectives. They could be mothers of children between 5 and 7, or teenagers planning to buy a new phone in the next 3 months. This is often done through professional recruiters who manage lists of people who've agreed to participate in focus groups for payment or other rewards. During a session, participants are asked to respond to various prompts from the group moderator, like sharing their opinions on a certain product or their emotional reactions to an advertisement. They may even be asked to do seemingly unrelated tasks, like imagining brands as animals in a zoo. The idea is that this can reveal useful information about the participants' feelings that traditional questions might not get to. Beyond these basics, many variations are possible. A focus group may have 2 or more moderators, perhaps taking opposite sides on a question. Or a researcher might be hidden in the focus group, unknown to other participants, to see how their answers can be influenced. And the whole process may also be observed by researchers through a one-way mirror. But although they can provide valuable insight, focus groups do have their limitations, and one of the main ones is that the simple act of observing something can change it. This principle is called observer interference. The answers participants give are likely to be affected by the presence of the researchers, social pressure from the rest of the group, or simply knowing that they're taking part in a focus group. And because researchers often use a small sample size in a specific setting, it's hard to generalize their results. The findings that researchers do reach from focus groups are often tested through experiments and data gathering. Those put numbers on questions like how many potential customers there are and what price they'd be willing to pay. This part of the process changes as technology evolves. But focus groups have remained largely the same for decades. Perhaps when it comes to the big important questions, there's no substitute for people genuinely interacting with each other.
Yeah, that's a good video on what like what focus groups are. Like a lot of corporations use them for figuring out how to sell their product. So you can easily do a study on, you make a focus group, and then you can kind of determine their opinions on a topic, like what during the 2000s they used to do focus groups on the war on terror, and they used a lot of the opinions of people in the focus groups to say certain words that might make people more supporters of the war. So that was used during the war in Iraq, just to try to get public support for the war. So like they do stuff like that. Like focus groups are used to find what words work in terms of persuading people to support something. So we're gonna go through sample size today, but there's a few other things that we'll go through in the weeks ahead, like sample data, hypothesis testing, qualitative statistics, and managerial implications. So sampling is a decision to survey the whole or a part of the population that is studied, so that results from analyzing the sample or generalized population. So the sample will often be smaller or much smaller than population. So the question is, will the sample reflect the characteristics of the population? So with that, how, like, with this, with this, what would make the sample represent the population? In your view? So like unbiasedness, so like the data is accurate, the surveyor doesn't change the data. Also, the group in the the sample has randomly chosen people. So that's a big part of it. So then, yeah, that's a big part of it. Yeah. So like if you have this, then you're gonna be fine. You're gonna have good data. So yeah, it has to be randomly selected. Like you have to choose the people randomly. So like how can we choose people randomly if you had, like, how can we choose people randomly? So what we could do to choose people randomly is we could draw popsicle sticks. That's possible. We could use a random number generator. Each person is represented by a number. This would ensure the data is unbiased. So yeah, like we want to find a way to represent the population without trying to get everyone in the population to answer. So we get like a small section. So let's say 10,000 people out of 30 million people. We want to get that. And so let's say it's like 10,000 people sample, 35 million population. In order to have the sample represent the population, we have to randomly pick 10,000 people from 35 million people. This is the only way, because we won't be picking people based on a certain income, education, or etc. So yeah, like we have to randomly pick that in order for it to be unbiased. So this is what they do. This is what they do with the Canadian census. So the Canadian census is taken every few years, and this is what they do with it to get stats on unemployment, income, education, all that information, GDP. So that's extremely important for getting the data on that. And then population is the entire group that is under study. Element is a single member of the population. Sample is a subset of population, a selected range of elements. Subject is a single member of the sample. Parameters are characteristics, central tendency, and distribution of the population. Sample characteristics should be the same. So the population should be defined in terms of elements, geographic boundaries, and time. So that's like, so in that case, so like Canada during the year 2022, let's say, that would be the population. And then sample frame, we have to determine the amount of people. And then sample design, we have to determine what money we have and time we have and sampling frame. So we have to determine the appropriate sample size. In this so sample size, the higher the sample size, the better. Like you'll get better results based on like if you have a higher, like the higher the sample size, the better for unbiasedness. So like you want to have a higher sample size. But like I said, like if the sample is random, it doesn't matter. Like you don't need a high sample size. So that's very important there. So yeah, the simple random sampling is when every element it has equal chance. And then complex probability sampling is when like there's a lot of different complicated things to do for complex probability sampling. Like systematic is based on intervals, stratified is based on subsets and population. So like for stratified, you have 15 in each age group. So like that gets complicated because you're putting equal weighting for each age group, which makes it complicated. Then cluster sampling, you have clusters, and then double sampling. When you do further sampling from the sample you got, you do another sample of that sample. It gets more complicated, but like I just recommend randomly sampling things instead of using these complex techniques. Just randomly sample from the population. So like randomly sample from, let's say, if you want to do from age 20 to 29, so randomly sample from that age group, and don't weight it based on each age, like 15 students, 15 people from 21, 15 people from 22, so on. Like I'd recommend just randomly sample from like an age, a range of age groups, range of incomes, range of education, etc., or just population. So why two columns of the number of subjects, i.e. sample design, which one is better or why, and why? So which one would be better, proportionate or disproportionate? Okay, I'm back. So confidence. So they usually use the 5%, the 95% confidence level. So that's important for the significance testing. So if your t-value is greater than 1.96 or less than negative 1.96, it's statistically significant. So that's the same. Then if it's the same as if the p-value is less than 0.05, same thing. It's statistically significant. So that's going to be, we're going to cover that a bit. So that'll be shown if you do a regression. You'll see the t-value and the p-value. So so confidence is it's an important thing in statistics. Like you want your p-value to be, like you want your t-statistic to be greater than 1.96 or less than 1.96, or p-value less than 0.05. So you want that. The statistical significance, I'm going to put up a video on that. I'm going to put up the video.
What's it like to learn math on Brilliant.org? Brilliant gets you hands-on to help you learn by doing from every.
Understanding statistical significance. Hi, I'm Dr. Nick from Statistics Learning Centre and Creative Maths. In this video, I'm going to talk about what statistical significance is. Sometimes people ask me how they can tell if their results are significant. Now, the problem with the word significant is that it has different meanings in everyday language than it does in statistical language. In everyday language, significant can mean big or it can mean important. For example, we could say my earnings are significantly more this year than they were last year. That means that the difference is quite big. So significant in that particular instance means big. Or we could say that there's been a significant increase in sea temperature. Now that increase is important, but it may be quite small. So those are two everyday meanings of significant. Big and important are everyday meanings of the word significant. But in statistical analysis, the word significant means something quite different. Something can be statistically significant and be small and unimportant. This is a problem with news reports, because when people say that the results are significant, people think that means big and important, but in fact, it might not be. When a result is statistically significant, that means that we have evidence from our sample that the effect that's in the sample exists also in the population. Now, you need to understand what sample and population are to understand this, so if you don't, it would be good to look at our video on understanding inference or understanding confidence intervals. Generally, we use a p-value to decide if something is statistically significant. We use the p-value to determine if the effect that shows up in the sample indicates that there's an effect in the population, or could it have occurred simply by chance or by sampling error. Generally, when a p-value is less than 0.05, we say that the result is statistically significant. We have evidence that the effect exists in the population. When we reject the null hypothesis, which is that there is no effect, we are saying that there is an effect and that the result is statistically significant. So low p-value, reject the null hypothesis, statistically significant result. If you have a really large sample, then just about anything is statistically significant. You could have a very small effect, but because our sample is so big, it's a really good representation of the population, and so we can just say, well, it is statistically significant, but it could be absolutely pointless. If you have a very small sample, it is unlikely that your result will show up as statistically significant, unless there's a remarkably large effect. And in terms of what words you use, it's a good idea when writing up an analysis to use the term statistically significant. Don't use the word significant on its own, and definitely don't use it to mean big or important in a statistical report. Some useful words you could use instead are notable, remarkable, compelling, measurable, or even large. For more about statistical significance, watch the video Important Statistical Concepts. This was Understanding.
So that's a good video on that. So if you have high statistical significance for your sample, then it's probably going to happen the same in the population. So that means your sample is a good sample. So like with that, so statistical, like if the t-statistic is greater than 1.96 or less than -1.96, p-value less than 0.05, the result is statistically significant and the sample is high, is a good representation of the population. So that's a very important part of that video. So then the sample size is a function of the variability of the population, precision or accuracy needed or desired, confidence level needed or desired, the type of sample design used, simple random sampling versus stratified random sampling. The sample size should not be too small, poor representation. Therefore could not extrapolate the characteristics of the population, or too large, costly, time consuming. So you want to have it high enough that it's not like high enough that there's no that it's a good representation of the population, but not too high for high costs. So then when all factors are taken into consideration, this table proposes sample size for range of population size. So this is a good table. So if for your research, so N is the population. and then sample size is S. So like, so for like, it's like this. So sample size of 384 is good for this number. Sample size of 382 is good for 75,000, so on. It's a good table on showing that the sample size is S, and then N is the population. It's a good table showing the 381 is good for 50,000, 380 sample is good for 40,000 population, 379 example is good for 30,000 population, 377 sample is good for 20,000 population, and so on. So it's a good table showing you a guide for what types of samples you should have based on the population. So assumes the researcher wants a representative sample that can express the characteristics of the population. So sample 30 between 30 and 500. Sample size should be 10 times larger than the number of variables in the study. So if you have like 5 variables, the sample size should be 50, at least 50. So that's important. So we've run through all these words: sampling, population, element, sample, sampling unit, subject, parameters, normal distribution, sample size, and systematic sampling, random sampling, convenience sampling, judgment sampling, quota sampling, sampling design, systematic sampling, cluster sampling, double sampling, rule of thumb. Sampling is done to allow the researcher